Good day. The topic we are treating today is statistics, mainly on examples on mean, median, and mode of grouped and ungrouped data by Monserrat. The objective of this video is to solve examples on mean, median, and mode of grouped and ungrouped data, so that by the end of the lesson, you should be able to solve different examples on mean, median, and mode of grouped and ungrouped data. Prerequisite topics are tabular representation of data for both grouped and ungrouped data and measure of location, where we talk about how to obtain the mean of grouped and ungrouped data, the median of grouped and ungrouped data, and mode of grouped and ungrouped data. Now we solve examples, and the examples are from the past UTME questions. So we move to the first example. In the first example, we are given a table of score and the frequency, which we know as the number of times a particular item occur. So the number of times the score 4 occur is 3, the number of times score 7 occur is 5, and so on. So the question says we should find the mean score of the distribution. So here we find the mean score. We can see that this is an ungrouped data, but it is large. That is why they have to put it in the frequency table. It is ungrouped. We can see that we don't have any class interval. We have just a single numbers for the column of items. So this is an ungrouped data. So we will solve for the mean using the formula for finding the mean of ungrouped data when the number of items is large. So if you are very conversant with the measure of location of finding mean of ungrouped data when the number of items is large, you know how to solve these questions. So now, score booster solution. The first thing we do is construct a frequency table, and the frequency table will consist of the score, which will be the item column tagged as S high, the frequency, which is the frequency of the scores, which is f of x subscript I, and the third column will be where we multiply the score by its frequency. If you want to know the number, if you want to add all this together, it's either you add 4 tries or you multiply 4 by 3. If you should add 4 tries, you have 12, and if you should multiply 4 by 3, we also have 12. So that is why we have the column f of xi, which is the frequency of the item multiplied by the item, to know the total number of times the score 4 occurs. So this is the frequency table. This is the column for the score, which is already given the frequency. Then we sum up the frequency, which is summation f of xi equals 20. So if you already know about a measure of location, where we talk about how to obtain the mean of ungrouped data when the number of items is large, you understand what we are doing here. So the next thing is for you to multiply 4 by 3, which is 12. If you want to find the mean of an ungrouped data, you sum up all the items in that data. So here we have 4 occurs 3 times. It's like adding 4 tries. 4 plus 4 8, 8 plus 4 12, and same thing as multiplying 4 by its frequency, which is also 12. So 7 occurs 5 times. 7 multiplied by 5 will give 35. 8 occurs twice. 8 multiplied by 2 16. 11 occurs 7 times, which will be 11 multiplied by 7 77. 13 multiplied by 2 will give 26. 8 multiplied by 1 will give 8. So to find the mean of this data, the mean of a set of data equals the total number of items in that set of data divided by the number of items in the set of data. So the total number here, if you should sum all the items together, it will be 12 plus 35 plus 16 plus 7 plus 26 plus 28 will be 174. And if you count the data one after the other, you count 4 tries, that will be 3. 7 5 times 8, 8 plus 2 10, 10 plus 7, 17, 17 plus 2, 19, 19 plus 1, 20. So the formula for the mean is the sum of all the items in that data, which is this, divided by the total number of items in the data. So this is the sum of all the items in that set of data, and this is the total number of items in that set of data. So the sum here from this place is 174 divided by 20. And that is what we have here. And if you divide 174 by 20, we have 8.7. Therefore, the mean of the distribution is 8.7. So that is that on that. So we move to the second question. The second question, we are to find the mean of this data: 7, minus 3, 4, minus 2, 5, minus 9, 4, 8, minus 6, 12. This is also a UTME past question, UTME 2002. So from this we can see that this is also a question about mean of ungrouped data, but here the number of items is not large. We have only 10 numbers. So from our definition, this is the mean of this data. It will be obtained by summing up these numbers and then dividing it by the total number of items that is here. So that is why we have x bar, which is what we use to represent the mean, equals to summation. This is summation sign as I've explained earlier. I, we start from 1, which is the first item, to the 10th item, and this is x high. So if we start when I is 1, we have x1, which is the first item. The first item is 7. When I increase by 1, we have 2, and we have x2. This will signify the plus. X1 plus x2 plus x3 up to x10, and divide by n. N is the total number of items in that data, and if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n is 10. So substitute these parameters into the formula. X bar will now be equals to x1 plus x2 plus x3 up to x10 divided by 10. So we're now fixing the values of the x highs, which is this. That is the values we have in the set of data. So we have 7 plus minus 3 plus 4 up to the last, which is x10, which is 12. Now divide the sum of all these, divide it by 10. So if you sum this up, we have 20 divided by 10. So 20 divided by 10 is 2. Therefore, the mean of the data is 2. That is the mean of this data given. 7, minus 3 up to 12, their mean is 2. That is the average. So now we move to the third question. The third question also says, by how much is the mean of these numbers, these 6 numbers, less than the median? So here we obtain the mean of these numbers, we obtain the median, then we subtract the mean from the median to know how large the median is than the mean. So now we move to the solution. This is also a UTME past question, UTME 2003. So we move to the solution. The first thing we do is to obtain the mean. This is also like obtaining the mean of the previous question. Here we have 6 items in all. If you count, you have 1, 2, 3, 4, 5, 6. So our n will be 6, and to stop at 6 because we have only 6 items. I will start from the first item to the 6th item. So that is why we have this x1. This signifies the addition sign, plus s2 plus s3 up to the last item x6 divided by the total number of items, which is 6. So from the question, x1 is 30, x2 is 56, s3 is 31, x4 is 55, x5 is 43, and x6 is 44 divided by 6. So we sum this up, we have 259 divided by 6, which same thing as writing 43.17. So that is how to obtain the mean. So now we obtain the median because we want to see how large the median is than the mean. We obtain the median of the set of data. So if you want to obtain the median, if you are conversant with the topic measure of location, you know the first thing we do is to arrange the numbers in order of magnitude, either ascending or descending. So here we choose to arrange in ascending order, that is from lowest to highest. So the lowest number is 30, followed by 31, followed by 43, up to the highest, which is 56. So we have arranged the number in the order of magnitude. So if you should count the number of items we have 6 items, and 6 is even. 6 is an even number. And from the way we can obtain the median of set of data, if you have a median of ungrouped data, that is data that are not that much, and if the total number of items we have is even, the only way to obtain the median is to sum up the two middle numbers and divide them by 2. That is, we look for the average of the two middle numbers. If you can't, you know this is 1, 2, 1, 2. This is 43 and 44. That are the two middle numbers. They are in the middle, but they are 2. We can't say 43 is the middle number, and we can't say 44 is the middle number. So we'll pick the two middle numbers, which are 43 and 44, and we divide them by 2. So the median will be equals to the first middle number 43 plus the second middle number 44 divided by 2. So this will be 87 divided by 2, which is 43.5. Now we obtain the difference between the mean and the median for us to know how large the median is than the mean. So the median is 43.5 minus the mean, which is 43.17. If we should deduct this from this, we have 0.33. Therefore, the mean is less than the data by 0.33, and that solves the question. So here we talk about how to obtain the mean of ungrouped data, and also how to obtain the median of ungrouped data when the number of items is even. So we can also meet some other questions where we have the number of items to be odd. So now we move to the fourth question. The fourth question says 5, 8, 6 and k occur with frequencies 3, 2, 4 and 1 respectively. That is, 5 occurs thrice, 8 occurs twice, 6 occurs 4 times, and k occurs once. We don't know the value of k, and the mean of this set of data is 5.7. So we have to find the value of k. This is also a UTME past question. We can see that here we were given the mean of this set of data. It is also like the mean of ungrouped data with large number of items, where we have to construct a frequency table for each number of items. So here the frequency of 5 is 3. That is, we can add 5 thrice or multiply 5 by 3. The frequency of 8 is 2, which means we can add 8 twice, or we multiply 8 by 2, like I explained in the first example. So now, after then, we find the mean, and we are already given the value for the mean, so we can use that to obtain the unknown, which is k. So now we move to the solution. From the question, the mean is 5.7. It has been given from the question. So the next thing we do is construct a frequency table for this information given, that 5, 8, 6 and k occur with frequencies 3, 2, 4 and 1. So we construct the frequency table. You know the frequency table will consist of the item column, the frequency of the item column, and where we multiply the frequency by the item, which is here, and that is the same thing we did in the first example. So they said 5, 8, 6 and k add frequencies 3, 2, 4 and 1 respectively, and for us to know the total number of 5s that are in the item, we multiply 5 by its frequency, which is 5 multiplied by 3, which is 15, 8 multiplied by 2, 16, 6 multiplied by 4, 24, and k multiplied by 1, k. So we sum this up: 3 plus 2, 5, 5 plus 4, 9, 9 plus 1, 10. And we also sum this up: 15 plus 16, 31, 31 plus 24, 55. So this is a variable, that is why we have 55 plus the last number which we don't know, which is k. So in this column, the summation of all the numbers in this column is 55 plus k, and summation for the frequency column is 10. So we already know that the formula for the mean equals summation of all this divided by summation of the frequency. So here we're given the value of mean already to be 5.7, which will now be equals to 55 plus k, which is summation of all this, multiplied by, divided by the summation of the frequency of the item, which is 10. So now we can cross multiply. This will go here, this will multiply the one under 5.7. So we have 5.7 multiplied by 10 will give 57 equals 55 plus k. So we collect like terms. This 55 will come to this side, we have minus 55. So k will be equals to 57 minus 55, which is 2. Therefore the value of k is 2. So if we should plug in the value of k to be 2 here, 2 multiplied by 1 will give 2. If we should add this together, we have 55 plus 2, 57. 57 plus 10 will now give 5.7, which is the value for the mean. That is how to check if your answer is correct. So the value of k is 2, and that solves the question. So now we move to the next question, which is also on mean of ungrouped data. So here we have to obtain the mean of this numbers t plus 2, 2t minus 4, 3t plus 2, and 2t. So this is also like the second question, which is the mean of ungrouped data where the number of items is not large. So we use this formula. X bar equals the sum of all the items in the set of data divided by the number of items in the set of data. And number of items here is 1, 2, 3, 4. That is why it is stopping at 4 here, which will be summation, which this is what calls for the addition sign. High starting from 1 to the last item, which is the fourth item, xi divided by the total number of items in the set of data. So this, if you should expand this, we have the first one when I is 1, x1 plus we increase I by 1, x2 up to the last item, x4, and total number of items in the set of data is 4. So what is the value for x1? T plus 2. The value for s2, 2t minus 4. The value for s3, 3t plus 2. And the value for x4 is 2t. So substitute that into the formula. We have t plus 2 plus 2t minus 4 plus 3t plus 2 plus 2t. If we should evaluate all those, we have 8t divided by 4. And 8t divided by 4 is 2t. Therefore, the mean of the set of data is 2t. And that solves the question. So now we move to the sixth question. In the sixth question, we're given a table, a frequency table. It is ungrouped frequency table because we don't have anything like class interval, maybe saying from 0 to something. This is ungrouped, but the number of items here is large. That is why we have to put it in the frequency table. So the number 0 occurs 1, number 1 occurs 4 times, number 2 occurs thrice, number 3 occurs 8 times, number 4 occurs twice, and number 5 occurs 5 times. That is how to interpret a frequency table. So if you finish interpreting the frequency table, the question says we should find the median and range of the data. So we have to find the median of an ungrouped data when the number of items is large. The number of items here is large, and see that is why we have to group them. We have to put them in the frequency table. So we have to find the median and also the range of the data. And what is the formula for range? The highest number, we subtract the lowest number from the highest number. So now we move to solution. The first thing we do is to obtain the median. So if you are conversant with the video measure of location, where we talk about the median of ungrouped data when the number of items is large, you know the first thing to do is to construct a cumulative frequency table. We all know how to obtain the cumulative frequency from the topic tabular representation of grouped and ungrouped data. So these are the numbers 0, 1, 2, 3, 4, 5, and these are the frequency. These two columns have been given from the question. So the only thing we do here is to obtain the cumulative frequency, and with the law of cumulative frequency, the cumulative frequency of the first class or first number equals to the frequency of that particular class or number. So the cumulative frequency of this will be equals to 1, since the frequency of this number 0 is 1, so the cumulative frequency here will be 1. So to get the cumulative frequency of the second number, you add the cumulative frequency of the first number to the frequency of the second number, which is 1 plus 4, 5. To get this, we add the cumulative frequency of the second number to the frequency of the third number, 5 plus 3, 8. So we do the same for everything. 8 plus 8, 16. 16 plus 2, 18. 18 plus 5, 23. And also the last cumulative frequency equals the total number of items we have in that set of data. And you know, to obtain the total number of items we have in the set of data, when we have a large item, we have to sum up the frequencies, which is 1 plus 4, 5, 5 plus 3, 8, 8 plus 8, 16, 16 plus 2, 18, and 18 plus 5, 23. So the total number of items we have in the set of data given is 23, and you can see that 23 is an odd number, because when we are dealing with median, we deal with odd and even numbers. So since the total number of items is odd, that is 23, as I've explained earlier, then we have to obtain the median value. We have to obtain where the median value is. So the median value will be equals to n plus 1 over 2 cumulative frequency. Assuming it is an odd number, the median value will be n over 2 plus n over 2 plus 1, everything over 2. Where it falls in the cumulative frequency, then the number of any item corresponding to that cumulative frequency will be the median value. So here, for us to know the median value, any number that is corresponding to, whenever we apply this formula, any value we obtain, where that value on the cumulative frequency column corresponds to any number, then that number would be the median. So here we now use this formula. N here is the total number of items. The number of items is 23. 23 plus 1 is 24. 24 divided by 2 is 12. So we go and check the 12th cumulative frequency. So the 12th cumulative frequency is here. You know, the greatest number here is 8. So this one, we start from 9. We start from 9 and we stop at 16. This we start from 9 and we stop at 16. So the numbers between 9 and 16 is where 3 will fall. So here 12 will be here. You know, 12 is between 9 and 16. So it is the 12th cumulative frequency that will give the median value, and the number that is corresponding to this 12th cumulative frequency is 3. Therefore, the number 3 is the median value of this set of data. So from the table, the 12th cumulative frequency corresponds to the number 3. Therefore, number 3 is the median. So now we move to the second question, which is where we have to obtain the range. And as I've said earlier, range is highest minus lowest number. So from the table, the highest number is 5. You can see the highest number is 5 and the lowest number is 0. So range will be equal to 5 minus 0, which is 5. Therefore, number 3 is the median and 5 is the range of the distribution. And that solves the question. So now, we also move to the 7th question. In the 7th question, we are to obtain the median of some numbers which are 15 in number. So this is also a UTME past question, UTM 2012. So we can see that we have to obtain the median of ungrouped data. Here the number of items is not large, so we don't have to put them in a frequency table. So if you have this kind of a thing, that is, if you are to obtain the median of ungrouped data when the number of items is not large, the first thing you do, as I've said earlier in an example we've solved before, we first arrange the numbers in order of magnitude, either ascending or descending. So here we choose to arrange the numbers in ascending order. That is, we start from the lowest. 2 occurs twice, 3 occurs thrice, 4 occurs 4 times. See it here. From here you can see 1, 2, another 2, that's all. 3, 3, 3, 3. So 2 occurs thrice. We have 2, another 2, then another 2. 3 occurs twice, 3 and 3. So the next number after 3 is 4. It also occurs thrice. So the next number after 4 is 5. You can see 5. How many times? 3 times. 1, 2, 3. We don't have any 6 here. The next number is 7 once. The next number is 8. It occurs once. And the last number, which is the highest number here, is 9, and it occurs twice. So that is how to arrange in ascending order. So if you want to arrange in descending order, that is from the highest to lowest, you start from the back. 9, 9, 8, 7, 5, 5, 5, 4, 4, 4, 3, 3, 2, 2, 2. So now, from this, we know that the total number of items is odd, which is 15. So median will be the middle number. So here, for you to determine the middle number, you divide 15 by 2, which is 7.5. If you approximate 7.5 to the nearest whole number, we have 8. So the 8th item will be the middle number. That is when you have odd number of items. If you have odd number of items, you choose the middle number to be the median. So here we have 15. If you have 15 items, so the middle number will be the 8th number. So we count from the right. 1, 2, 3, 4, 5, 6, 7, 8. It falls here. And which also counts from the right. 1, 2, 3, 4, 5, 6, 7, 8. You can see that it falls on a single number. So the median here, which is the middle number, is 4. Therefore, the median of these numbers is 4. That is the middle number. So it is easier for us to obtain the median of set of items when total number of items is odd. Just pick the middle number. But if total number of items is even, we pick the 2 middle numbers. Assuming we have just 14, we count 1, 2, 3, 4, 5, 6, 7. 14 divided by 2 will give 7. So you count 7 items from the right, 7 items from the left. Here we have 1, 2, 3, 4, 5, 6, 7 to fall on 4. We start here again. 1, 2, 3, 4, 5, 6, 7 to fall on another 4. So you add the 2 fours together and divide by 2. That is when the number of items is even. But when the number of items is odd, we take the middle number. So here, since we have an odd number of items, 15, you divide 15 by 2 and approximate to the nearest whole number, which is 8. So the 8th item will be the middle number. So the median of this set of data is 4, and that solves the question. So now we move to the 8th question. The 8th question says we are given class interval 0 to 2, 3 to 5, 6 to 8, 9 to 11, and these are their frequencies. So we are to obtain the mode of this distribution. This is also a UTME past question, UTME 2011. So from here we can see that this is a group data because you can see that these are grouped. The class intervals are grouped. We have class intervals. You can see from 0 to 2, from 3 to 5. So this is how to identify a group data. So the formula and the steps to take here will be the formula and steps to take for obtaining the mode of group data. So now we'll move to the solution. For you to obtain the mode of group data, the first thing you do is construct a frequency table consisting of the item, the class boundaries, you know how to obtain the class boundary of each class interval, and then the frequency. So now the class interval from 0 to 2, the next one is from 3 to 5, and these are the frequencies. So for you to obtain the lower, this is the lower class limit. If you are very conversant with tabular representation of grouped and ungrouped data, and also measure of location, you know how to obtain the lower class boundary. For you to obtain the lower class boundary, you subtract 1/2 of the units of measurement from the lower class limit. The unit of measurement here, you start from 0, you move to 1, then 2, so that we count in ones. So the unit of measurement is 1. So the lower class limit is 0. 0 minus 1/2 multiplied by 1. The same thing as saying 0 minus half. 0 minus half will give minus half, and minus half can also be written as minus 0.5 in decimal form. So that is how to obtain the lower class boundary. So to obtain the upper class boundary, we add 1/2 multiplied by the unit of measurement to the upper class limit, which is 2. Here the upper class limit for this class interval is 2, plus 1/2 multiplied by 1, which is 2, plus half, which is 2.5, which can also be written as 2.5. So we do the same thing for all other class intervals to get their lower class boundaries and upper class boundaries. So after we've constructed a frequency table consisting of the class boundary, the frequency, and class interval, the next thing to do is to identify the model class. And for you to identify the model class, you look for the class that has the highest frequency. Mode is about the number or item or class that has the highest frequency. So here the highest frequency here is 5, and if that frequency corresponds to the class 6 to 8, therefore the model class is the class 6 to 8. So now the next thing for us to do is to obtain the mode using the formula this. So this has been given. L1 is the lower class boundary of the model class, which is here the lower class boundary of 6 to 8. And see, this is the lower class boundary 5.5. F substitute S is the difference between the frequency of the model class and the class before it, which is 5 minus 2, which is 3. Fy is the difference between the frequency of the model class and the class after it. 5 minus 3 is 2. And C is the size or width of the model class, and the size or width of the model class can be obtained by subtracting the lower class boundary from the upper class boundary, which is 8.5 minus 5.5, which will give 3. Then substitute all those parameters into the formula to get the value for the mode. So this is what I just explained. L1 is 5.5, F substitute S is 3, S substitute Y is 2, and C is 3. So substitute into the formula. We have L1 plus Fs, which is 3, over Fs plus Fy. Fs is 3, Fy is 2, multiplied by 3. So if we should evaluate all this, 3 over 5 multiplied by 3, which is 9 over 5, which is same thing as saying 1.8. So we'll add 1.8 to 5.5 to get 7.3. Therefore, the mode of the distribution is 7.3. And that ends the question for this video. We'll continue the remaining question in the next video. Next video will be more sample questions and solutions on statistics, which will be mainly on mean, median, and mode of both grouped and ungrouped data. Please subscribe to our YouTube channel, like and share.